Welcome back, everyone. Today we're going to find the angle between each set of component vectors. So we have three different examples we'll be going through today, and they're all pretty much the same in terms of how we can figure it out. So in general, it is the case that cosine of angle theta, which is the angle between the two vectors, is going to be equal to the product of them, so A dot B, over the magnitude of A times the magnitude of B. Okay, so for this first one here, let's let vector A be equal to the first one, -3, 7, and let's let B be equal to 1, 4, like that. And now we need to find the dot product. So what is A dot B? Well, A dot B is going to be equal to -3 times 1 plus 7 times 4. Okay. And let's see, -3 times 1 is -3. 7 times 4 is 28. So therefore, the dot product between them is 25. Now we need to find the magnitude of A and the magnitude of B individually. So the magnitude of A is going to be equal to the square root of -3 squared plus 7 squared, which is equal to the square root of 9 plus 49, which is equal to the square root of 58. Then for the magnitude of vector B, that's going to be equal to the square root of 1 squared plus 4 squared, which is equal to the square root of 1 plus 16, which is equal to the square root of 17. So therefore, the answer to this is that cosine of theta is equal to 25 over root 58 root 17. So now what we're going to do is we're going to grab our calculator and we're going to find the inverse of cosine, right, of 25 over root 58 root 17. And if we do that, we get that theta is equal to approximately 37.3 degrees. So therefore, the approximate angle between each set of between these component vectors is 37.3 degrees. Okay, let's do another one. And actually, I might give myself more room this time. That felt very crammed in there. Okay, so for this one, same sort of thing. We're going to let vector A be equal to 0, 6, and we're going to let vector B be equal to 3, -2. So the dot product, A dot B, is going to be 0 times 3 plus 6 times -2, which is 0 plus -12, which is -12. The magnitude of A is the square root of 0 squared plus 6 squared, which is the square root of 36, which is 6. And then the absolute, or the magnitude of B is equal to the square root of 3 squared plus -2 squared, which is equal to the square root of 9 plus 4, which is equal to root 13. So now let's recognize that cosine theta is equal to A dot B over magnitude A magnitude B. Therefore, cosine of theta is equal to 12 over 6 root 13. So now if I grab my calculator and I type in the inverse of cosine of 12 over 6 times the square root of 13, I get 56.3 approximately if we round to 1 decimal place. Awesome. Okay, and let's do one last one. Same kind of idea though. All right. So for this one, let's let A be 4, 7. And let's let B be -2, -5. So therefore, A dot B is equal to 4 times -2 plus 7 times -5, which is equal to -8 plus -35, which is equal to -8 minus 35, which is equal to -43. Then the magnitude of A is equal to the square root of 4 squared plus 7 squared, which is equal to the square root of 16 plus 49. And 16 plus 49 is 65, so this is the square root of 65. Okay, and then for the magnitude of B, that's going to be the square root of -2 squared plus -5 squared, which is equal to the square root of 4 plus 25, which is equal to the square root of 29. So therefore, we have cos theta is equal to A dot B over magnitude A magnitude B. So therefore, cos theta is equal to -43 over root 65 root 29. And then if I grab my calculator, I'm going to punch in inverse cosine here of -43 over root 65 root 29, and that is giving me 172.1 approximately degrees. Oh, I guess we can't see that. I'm going to put that here. 172.1 degrees. As always, if you have any questions, please leave them in the comment section, and we'll see you for the next one.